Today we're finishing up 3.1 and we're talking about multiplying polynomials. So go ahead and turn to page 4. Front of the room. Make sure it's the one that says math 2. So don't grab the one that says honors. There's one that should say math 2. All right, guys, do me a favor. Clamshell your Chromebooks for me. All right. So again, we talked about adding and subtracting, which was just combining like terms. Now we're going to talk about multiplying. All right. Again, this is still review. You learned this back in math 1. All right. So first off, we have the very easy multiplication, which is just multiplying any polynomial by a monomial. Remind me what a monomial is? Someone besides Owen. What's a monomial? Ephraim. A polynomial with one term. So when we multiply by a monomial, we just have to distribute. So we're using the distribute property. And then we also have to use the product rule for exponents. So remember, when you're using the product rule for exponents, you're multiplying the variables with the same base. All you do is add the exponents. Now, the coefficients, you still multiply like normal, but with the exponents, you just have to add the exponents. All right, so for example, if you had x squared times x cubed, what is that? What's x squared times x cubed? X to the 5th. All you do is just add these two exponents. That's all you got to do. All right, so let's look at these first couple problems. All right. So I'm going to distribute 3x squared to both of those terms in the binomial. Now remember, what's in front of this x is a 1. So you're going to multiply the coefficient of the monomial to all the coefficients in the binomial. And then the exponents we add on. So what's 3x squared times x? Nope. 3x, because 3 times 1 is 3. 3x what? 3x what? Cubed. Good. Because this is raised to the first power. 2 plus 1 is 3. So these you multiply like normal. So you just do 3 times 1. It's only the exponents you add. All right, what's 3x squared minus 7? Or, sorry, 3x squared times negative 7. Negative 21 x squared. So if it's a constant, whatever the other exponent is, you just slap it on. So this would be our answer. Now, this next one. So let's do this a piece at a time. All right. So let's start by distributing the coefficients to each other. So remember, if you're multiplying by 1/2, that's the same thing as doing what? Dividing by 2. All right, so what's 1/2 times 2? 1. All right, I'm going to leave some space. What's 1/2 times negative 10? Negative 5. I'm going to leave some space. What's 1/2 times 6? Positive 3. Again, I'm leaving space because we haven't multiplied the variables yet. Now I'm going to multiply the x's together. Even though there's no x here, we still got to assume that it's going to be there. So let's look at the first one. What's x times x squared? X cubed. X times x? x squared. And then what's x times 1? Because there's nothing there. X. All right, so those are the x's. So lastly, we're going to do the y's. All right, so what's y cubed times y squared? Y to the 5th, because 3 plus 2 is 5. It's the same thing for the negative 10xy squared. Still be y to the 5th. And what's y cubed times y cubed? Y to the 6th. So if doing it all together confuses you guys, by all means, break it apart based off of the type of variable and the coefficients. Totally fine. All right, take a minute. Try that next one on your own. All right, thumbs up if you're ready. All right, let's go over this. So we're distributing the negative 2x to all three of these terms. So let's go with Rayleigh. What is negative 2x times 4x squared? So negative 8x what? Not squared. Remember, add the exponents. Cubed. Good. All right, let's go with Cohen. Negative 2x times negative 10x. Not negative 20. Positive 20 what? X squared. Good. Finally, Owen. Negative 2x times negative 13.
So negative 2x times negative 13 would be positive 26x.
Good. Any questions on multiplying by monomials? So again, that's just distributive property. All right, now let's talk about multiplying binomials. So there are two methods when we multiply binomials. The first one is FOIL. All right, so FOIL just means first, outer, inner, last. All right, so if we broke it down, you would multiply the first terms together, the outer terms together, the inner terms together, and the last terms together. And then you would add them together, combine like terms. So for this one, the first x times x is x squared. The outer x times 2x, x times 2 is 2x. Inner 3 times x is 3x. And last 3 times 2 is 6. Only place that combines is typically the outer and inners. And that makes x squared plus 5x plus 6. Now remember, this is one of two methods that you can use for multiplying binomials. What's the other one? So what's the other method that you typically use to multiply polynomials together? So FOIL's one. What's the other one? Okay, we'll come back to it. All right, so let's FOIL these. So I'm going to do first. So what's x times x? X squared. I'm then going to do outers. So what's x times negative 2? Negative 2x. Inner, 4 times x, positive 4x. And then last, 4 times negative 2, negative 8. So if I combine like terms, what are my only two terms I can combine? Negative 2 and positive 4x. So someone different. What's that equal to? So I got x squared was negative 2x plus 4x. Positive 2x minus 8. All right. Now, the second one. What do I multiply together first?
Negative 8x times x.
So positive 8x times x,
Oh, right.
which is what? 8x squared. What do I do next? 8x and negative 4, which is what? Negative 32x. All right, someone who has not spoken yet today. What do I do next? Negative 3 times x, which is negative 3x. All right, someone else who has not spoken today. What do I do last? Negative 4 times negative 3, which is positive 12. Combine my two like terms, which is the negative 32x and negative 3x. So you just add them together. This would be 8x squared minus 35x plus 12. Now, this last one, this is probably one of the most common mistakes you will see. All right, because what a lot of people like to do is that they just square the x, square the negative 7, call it a day. That is not how you do these because the whole polynomial is squared. So what is technically x minus 7 squared? What's that the same as? How could I rewrite that expression? Right, this is exactly the same as x minus 7 times x minus 7. So in other words, guys, it won't be x squared minus 49 or x squared plus 49. There will be a singular x variable in there as well. It'll be a trinomial, not a binomial. So if you ever see one like that, it's not a trinomial. Sorry, it's not a binomial as your answer. It's going to be a trinomial as your answer. All right. So take a minute, do that one on your own. So FOIL that one through. Thumbs up if you're ready. Give you guys one more minute. Take a minute, compare answers with your group mates.
For this one, I got this. What did he get?
Alrighty, check your answer. So when I was looking around the room, most of you got that. All right, just be very careful because some mistakes that I did see was that some of you guys added the sevens instead of multiplied them. And then some of you guys canceled out these two 7x's. Remember, it's not negative 7x plus 7x, it's negative 7x minus 7x. So you would add those two negative 7s. All right. Now, I asked you guys earlier what the other method was. And that method is box method. So, I don't care which method you use as long as you know how to do one of them. So, whichever one you prefer, I don't care. Now, I will say, multiplying binomials, FOIL and box can be interchangeable. All right, it doesn't really matter which one you do. However, where box method outshines FOIL is when you are multiplying something greater than a binomial. So in other words, if you're doing a binomial times a trinomial, or a trinomial times a trinomial, box method is better than FOIL because you're less likely to forget a term. All right, doesn't mean it's impossible to FOIL, but at that point it's not FOIL anymore. It's just a lot of distributing. All right, so again, figure out which method you like best. But when it comes to multiplying anything higher than two binomials, I highly recommend doing box method. All right. So remember, box method is when you create a rectangular box with the first and second polynomial, and you're calculating by multiplying the length times the width. So in other words, it's like an area model. That's why it's called the area method. Okay. Then to find the total area, you combine like terms using the area of the individual pieces. So for this one, they're doing 2x minus 7 times 3x plus 5. They already went ahead and wrote them along the sides. And what they did is that you multiply row by column. So 3x times 2x, 3x times negative 7, 5 times 2x, 5 times negative 7. All right, you just multiply row by column to fit into these boxes. So let's go ahead and do that multiplication. So what's 2x times 3x? 6x squared. Negative 7 times 3x? Negative 21x. 2x times 5? 10x. Negative 7 times 5? Negative 35. Then we take everything out of the box and then combine like terms. Now, little trick here. Typically, this is not always true, but typically, the like terms are diagonal from each other. Typically. All right, that's not always true, but more often than not, that's what's true. So if I pulled everything out, it'd be 6x squared minus 21x plus 10x minus 35. And my two like terms again are the negative 21 and the 10x. So this would be 6x squared minus 11x minus 35. So again, box method is a more organized way of FOIL. One thing that I like about box method is that it ensures that you do not forget a term. All right, because with FOIL, that's kind of the mistake that you can make, especially once you get past binomials. Like, for example, if you try to FOIL letter E, you may miss a term. It's not impossible to do it. You just have to be really, really careful when you're doing it and make sure you don't forget to multiply each term to each other term. Okay, so now the size of your box depends on how many terms you have in each polynomial. So for example, letter D, how many terms are in each polynomial? 2. So that means we're making a 2 by 2 box. So you should have 2 columns and 2 rows. Whereas for E, what size box do you think I'm going to have? What size box? So I have a 2 by 2 for the first one. So what do you think the 2 by 3? Because it's a 2 term and a 3 term. So I need 3 columns and 2 rows. Now you could have done 3 rows and 2 columns. It doesn't matter. Just for space wise, I'm doing 3 columns, 2 rows. So let's set up letter D. Now, it does not matter if you have a square as your box, where you put the, which polynomial you put where. All right. So I'm going to put the 3x minus 4 across the top. Make sure that each term lines up with a row or column. And the x minus 8 on the side. You could completely flip-flopped it. It doesn't matter. So what's 3x times x? 3x squared. What's negative 4 times x? Negative 4x. 3x times negative 8? Negative 24x. And negative 8 times negative 4? Negative what? So negative 8 times negative 4 is? Positive 32. Now, we can then pull it all out. And again, a trick is if you don't want to have to rewrite every term and just want to go ahead and pull it out with combining like terms, remember the like terms are usually in the diagonal. So this would be 3x squared What's negative 24x minus 4x? Negative 28x plus 32. Now, when you have a true rectangle, meaning you have a different length and a different width as your box, that's when putting the correct polynomial in the correct spot holds up. So which polynomial goes on the side, the x minus 1 or the x squared plus 3x plus 4? X minus 1 goes on the side because that's the 2 term. So that means x squared plus 3x plus 4 goes on the top. And then it's just business as usual. So what's x times x squared? X cubed. 3x times x? 3x squared. 4 times x? 4x. Negative 1 times x squared? Negative x squared. 3x times negative 1? Negative 3x. Negative 1 times 4? Negative 4. So once again, remember, the diagonals are typically the like terms. So this time, this one has 2 sets of like terms. All right, the x squareds and the x's. So we bring out x cubed first. What's 3x minus x squared? Positive 2x squared. What's 4x minus 3x? Positive x. And then you bring out the negative 4. So guys, typically, this is how you know if you multiply correctly. Typically, if you have, and again, this isn't always true, but typically, the number of terms that you should have at the end should be one more than the polynomial with the most terms. So if you look, these are both binomials. We ended up with a trinomial. Our largest here is a trinomial. We ended up with a 4-term polynomial. Now, that's not always true, but it does, that's typically what happens most times. All right, the only exceptions is if you have like a difference of squares or if you have missing variables in the polynomial. So it doesn't just go x squared 3x4. It'll go like x squared plus 4 or something like that. All right. So this next one, all right, it asks us to find the area of the rectangle. So first off, what's the formula for area of a rectangle? Length times width. So in other words, I'm just going to multiply the length to the width. So take a minute and do that. So it's just either a box method or a FOIL, however you want to do it. But you're multiplying those two together. So you can either FOIL that one or you can box method. It doesn't matter as long as you multiply them together. Take a minute, share your answer with your group mates.
So this is what I got for numbers we have here. So I used the FOIL method. I eventually got 7x minus 5. What did you get?
Just too lazy to draw that.
All right, guys. Check your answer. Now, I boxed, but if you foiled, that's okay as long as you arrived at the same answer. So again, you didn't have to box. You could have foiled. I just do it because that's kind of the one I default to. All right, any questions on that one? All right, now, this next one. So, let's go ahead and box this one. So we know we're going to have a 2x2 box. X minus 9, I'm going to put on top. X plus 9, I'm going to put on the side. What's x times x? Squared. Negative 9 times x? Negative 9x. 9 times x? Negative 9 times positive 9. Negative 81. Now, here's my question. When I pull everything out and combine like terms, what's going to happen to the x's? They're going to cancel out and get 0. So this is actually x squared minus 81. Now, this polynomial has a special name. Does anyone remember what this type of polynomial is called? We typically use this phrase when we start factoring. Close? Nope. It does have square in it, in the name. I'll give you a hint. DOS. That's the acronym. DOS. Not domain, but is of squares. What operation is being done to those two terms? So x squared minus 81, what operation is that? Come on, guys. What operation is x squared minus 81? Subtraction. What's another name for subtraction that starts with a D? Come on, that's elementary school level. What's another name for subtraction that starts with a D? I take the blank of two numbers. Difference. This is called a difference of squares. So this is called a difference of squares because you're literally subtracting two perfect squares. Why am I bringing this up? You will see it again. All right, especially when we get to factoring. Now, this last one. So, first off, you do not start by multiplying the 2 in because we have to take care of the square first because by order of operations, you do exponents before multiplication. All right? But remember, x minus 10 squared is the same thing as what? Right. So technically, this is negative 2 times x minus 10 times x minus 10. So I need to box or FOIL those two first. Now, for time's sake, I'm just going to do a quick FOIL. So this will be negative 2 times x squared minus 10x plus 100. So I just did a very, very quick FOIL. So if I combine like terms, it's negative 2 times x squared minus 20x plus 100. Now, I'm not done because how do I finish this problem up? Distribute that negative 2. So negative 2 times x squared is negative 2x squared. Negative 2 times negative 20x. Positive 40x. And then negative 2 times 100. Negative 200. So if you ever see a problem like this, guys, expand this first. Do not distribute the negative 2 in until the very last step. Typically, if you have to multiply polynomials and then multiply what we call a scalar or a number into it, you do that last. All right, always multiply the polynomials first. Any questions on this? All right, so your assignment is still that 3.1 Delta Math that I assigned you guys on Friday. All right, so you guys got a solid 40 minutes to work on that. So that's what I expect you guys to be working on. You can also use this time if you want to do test corrections, or you can use this time to work on any makeup Delta Maths, whatever. Yes.